All right, today's lesson is on the squeeze theorem. You might also hear this referred to as the sandwich theorem. So this statement right here, it's kind of common sense. Once I explain it, you're going to be like, oh, yeah, well, duh. So what it is, for all values of x in the interval that contains a, and then we have these three functions, g of x, f of x, h of x. Notice how f of x is squeezed in between g and h. So if the limit as x approaches a of g of x is equal, so g of x is equal to the limit as x approaches that same value h of x, so if they equal that limit L, well then f of x also equals that same limit. So just to give a little visual, we're just going to kind of make up a little graph. And it has the x value a. Now I'm going to have three graphs. So let's start with h of x. Let's say h of x kind of comes down like this. Let me get a different color. Let's say g of x does this. And f of x, let's say, is squeezed in between them. So I know those are just kind of silly scribbles, but the idea is if I can't find the limit for f, but I know that it is squeezed in between h and g, if I can find the limit of h and I can find the limit of g, and if the limit of g equals h, then I can find the limit of f. It will equal the same thing. Okay, so here's an example. We want to evaluate the limit as x approaches 1 of f of x. And here we know that f of x is squeezed in between this g of x function and this h of x function. All right, well, let's look at the limit as x approaches 1 of the g function 5. Well, in this case, that equals 5. So let's test the other side, the h function. So the limit as x approaches 1 of x squared plus 6x minus 2. Let's see, 1 squared plus 6 times 1 minus 2. That equals 5. So because x is approaching 1, and we know both sides equal 5, and I know that function f is squeezed in between them, therefore, the limit as x approaches 1 of f of x has to also equal 5. Okay, so I often see this squeeze theorem used in problems like this, where we have trig, sine, and cosine. So the limit as x approaches 0 of x squared times the sine squared 1 over x. So I can't plug in 0. That's going to cause a problem. So one way to think about this. First, I want us to think about just some basic trig functions here. Here I have just a quick sketch of like sine x and cosine x. Notice how their graphs, we always are going from -1 to 1. And that range is true for functions like sine of 1 over x and cosine of 1 over x. Those functions are always ranging from, let me write this out, they're from -1 to 1. But now for this example, it's sine squared. So sine squared is actually in between 0 and 1. So what I'm going to do is take just this part of the function, sine squared of 1 over x is in between 0 and positive 1. Now, if I want to add in this x squared, I can multiply all three sides by x squared. So 0 times x squared is still 0, less than or equal to x squared times sine squared 1 over x, less than or equal to 1 times x squared is x squared. So this function is sandwiched or squeezed in between these two functions. So now let's take the limit as x approaches 0 of the left function, which is 0, well, that's just 0. And then the right side, the limit as x approaches 0 of x squared, well, that also equals 0. So this function, if it's in between these two where the limits as x approaches 0 are both 0, then that means this one, the limit as x approaches 0 of x squared times sine squared of 1 over x is also 0. Okay, here is last example. G of x, got this function, and then I have h of x, and what we need to find is the limit as x approaches negative 1 of f of x. So because f of x is sandwiched in between, I'm going to find the limit of g and h. So the limit as x approaches negative 1 of g of x, so of negative 3x squared plus x plus 1. Let's see what that equals. If I plug in negative 1, negative 3 times negative 1 squared plus negative 1 plus 1. So I'm looking at negative 3, take away 1, negative 4 plus 1 goes back to negative 3. All right, now let's look at h of x. So the limit as x approaches negative 1 of x minus 2. If I plug in negative 1, that equals negative 3. So because the limit of the two sides as x approaches negative 1 are both negative 3, then the limit as x approaches negative 1 of that f of x has to equal negative 3. All right, there is the full video on the squeeze theorem. Good luck with your lesson.